Hi, Itesh. How are
Hey,
you?
good morning, Alexei. Can you hear me?
We can hear you. Probably you muted or something. We make a switch camera so you can see people. They will actually be gathering right now.
Sounds good. Take your time.
Um,
Can you hear me?
yeah, can you say something?
Yes, I'm saying something. Can you hear me?
No, we can hear.
А у нас ты сколько носишь?
Maybe we have some issues. Yeah, we cannot hear you.
Ah, okay. I can hear you.
Um,
Oh, by the way, our speakers broke at the last lecture. Like we didn't hear the speaker at all.
but you can hear me. Yeah.
Yeah. Ah,
Oh, can you say something now? I think maybe if you fix it.
Can you hear me?
Yes.
Lovely. I wish everyone could be as happy on hearing me as you all are. Can we just do it every morning where you get so happy to hear my voice?
Yes.
No one else does. I need this group every time.
there's some echo. No. No.
Okay, I think we can start if it's fine.
Sure, give me like 2 minutes.
Oh, okay. Oh, sure.
There's no echo.
Echo.
Ну, більше немає. Було, більше немає.
All right. I'm assuming you all can see the slides.
Yeah.
Fantastic. So yesterday we left at the topic of, can we use metrics to overcome the challenge of class imbalance? And do we have to always do sampling, etc.? And I presented to you a metric that we formulated based on Hellinger distance, and we created the Hellinger distance decision trees. So that's all good, right? So then in the more recently, one of my PhD students, and this was his KDD paper last year. He has a longer paper as well going to another journal, but the question he began to ask is, could we take any classification metric uh, based on a confusion matrix and convert it into a loss function? The problem here is, if you and the goal is to actually be able to use a loss function for neural networks, and neural networks require a differentiable loss function. So if you remember, for anything we do with neural networks, we're computing gradient descents, right? Because that's what we're optimizing on. And whether we are doing error, and then we have a loss that we calculate using logistic or tanh, etc. But each of those loss functions is essentially a differentiable loss function because we are computing gradients. So the question was, and as a result, we get limited to optimizing mean squared error, sum squared error, etc. Can we take any given a confusion matrix as follows? Could we optimize it and create a differentiable confusion matrix? Um, and again, as I said, the reason was one of the things that we struggle with neural networks today and the applications for imbalanced data set is that they are, whether it's binary cross entropy or mean squared error, they are all accuracy based, because that's what we are differentiating on. That's what our objective function is essentially centered on, is I'm going to reduce my error. I'm going to, even if I'm doing logistic or tanh, at the end of the day, the functional computation of tanh or logistic is on error or binary cross entropy even. So, if you're limited, any gradient or difference or any partial derivatives I calculate is going to be on error. So what we then sort of did here is that we created an approximation mechanism, right? So we essentially said, can we begin to approximate that if given a actual class of true negative, again, we are starting from a confusion matrix. At the end of the day, in the previous slide, as I showed, you have a confusion matrix, and I'd even shown it to you yesterday or 2 days ago, where you have actual class, predicted class, that becomes a true negative. And again, our class one, always, the minority class, is going to be the positive class, right? So, and we calculate our accuracy or error based on how many true negatives I had or how many true positives I had, and my error rate is false positive, false negative. These are discrete values. These are non-differentiable. These are discrete values. So then we have we have transformed the discrete values using, and we say that there's a y hat approximation, which is the actual. So if y is the actual class, we say y hat is an approximated class, and the y hat approximated class follows the one minus y times 1 minus y h calculation, and YH is the approximation that we are doing, which is based on a hyperparameter. We are essentially creating a distribution, logistic distribution, if you will, on the actual class. And it creates a probability of YH close to the actual labels, but it is still differentiable, because now we are trying to get it to a form where it's not discrete. If it were discrete, then it cannot be differentiated, right? So we are getting it to a form, an approximation function, using a logistic form here, where it becomes a differentiable approximation, where the class is an approximation on the actual true class. And hence we compute the loss function now is the differentiable form of true negatives, false positives, and true positives. And then we can compute F-score or balance accuracy to optimize as a loss function. Until our paper that we published in KDD last year, there was no way of optimizing or optimizing directly on a loss function that was more attuned to imbalanced data, right? F measure or balance accuracy is more attuned to imbalanced data. But until we did this work, everything within the neural network was error-based. So these were not attuned to imbalanced data. By using F measure balance accuracy, we did arrive at a mechanism or a framework which was more attuned to imbalanced data as a result. So I hope that intuition is clear, is that what we are trying to get done here is we are taking the confusion matrix, again, creating an approximation of the true label. Based on that approximation, we're computing a loss function. And that loss function, we are able to now derive my F measure as well as my balance accuracy. Why are we doing it? Because F measure and balance accuracy are much better metrics for imbalanced data than simply using error, because my error rate could be very low to begin with if the data is highly imbalanced. If my data has one class is 99%, the other class is 1%, it's a highly imbalanced data. What's the point of, error is 0.01? What do you optimize on, right? So the balance accuracy or F measure is a more accurate way of figuring out how do we optimize on the loss function. And then the other research question that we had related was, can any loss generate optimized scores for any targeted metric regardless of data sets? Is any loss more effective with imbalanced data sets? And is the learning speed of any loss competitive against the baselines? These were the three research questions then we asked once we set up the formulation. And we used about 102 data sets in our experiments, including a variety of randomly generated data sets. And what we see is that any loss achieves a significantly better performance across the board over 102 different data sets. And the beauty of this any loss is that even though we designed it to work on imbalanced data sets, even though it was designed for that, it works irrespective, because of the 102 data sets we had a varying degrees of class distribution. Some were more balanced, some were less balanced, some were more imbalanced, and we were able to achieve a fairly effective accuracy of performance across the board for the variety of data sets. So this was a very strong and encouraging result. And this sort of gives you a sense of how much it does better over the baselines. Whether it's LF is F measure based score and LB is balance accuracy based optimization. And again, this continues with a variety of different data sets across the metric, across the domain, across the imbalance domain. And the results support this. It's also quite efficient, as the results support, that it's not actually creating any significant more computational burden than otherwise. So I highly encourage you all to use any loss, and we have the code and everything available for training your neural networks, etc., because then you don't have to worry about the imbalanced data distribution of the performance metric that you're using, because it's agnostic to the class distribution, it's agnostic to the performance measure that you may use to evaluate the performance of a classifier. All right. So now we are sort of going to change the flavor of the talk just a bit. I wanted to finish the portion of the imbalanced data quickly. And, if you have, I'm happy to share the slides with all the papers, etc., after these talks as well. And so if you want to have them as a reference point. So let me ask everyone in the room. Clearly folks here in the room who are attending this summer school have been doing AI, or it could be you could be AI experts already, or you could be starting your journey of AI, or you could have intermediate AI expertise. You could have a variety of things. Let me ask you one thing. How would you define AI? I'm going to stop sharing my screen so I can see you all. How would you define AI? Volunteer, please.
How we can define AI?
How would you define AI? What is AI?
Linear algebra.
My answer.
It's a really hard question, but maybe something that can make symbolic inferences about unstructured data.
Symbolic inferences about structured data.
Yeah.
Anyone else? That's a valid definition.
Today, when I hear AI, I usually think LLM.
LLM.
That's what people mean.
Yes. But if not today, yesterday, what would have you thought? Before LLMs.
No? No. Maybe not.
Yeah, come on, folks. They honestly, there's no wrong answer.
Maybe we have options to watch what is program coding in that object or data science. How
So say that
how-
again. I'm sorry. Could you repeat that?
and how
Питание, что такое штучный интеллект?
там он спрашивал вроде по как распознать, нет? Не то?
Что такое штучный интеллект?
Тогда сори. Я просто не понял. Ну, как
Okay.
распознать.
Generally, I feel when people talk about AI, they think about HI. In my opinion, AI is field in computer science, which try to deal with different methods, which try to emulate some kind of different features of intelligence. For example, learn, make decision in uncertainty, and other stuff.
All right, sounds good. So learning and decision making. So three answers that we have heard is symbolic inferencing or whatever LLMs do, as well as learning decision making. Anything else that you may anyone wants to add as a perspective on definition of AI?
Okay, so maybe AI is a non-living system that can connect the target and the input data or make a decision on someone. But the point is that it's non-living or non-human being intelligence.
Okay.
Yeah, maybe also another definition can be that something, again, that's artificial, but it can interact with the environment. So something that interacts with the environment, gets input from the environment and does something to the environment.
All right, environmental interactions as well. Good.
Yeah, now I think it's time for you to give an answer.
All right. So I think so. Thank you all so much. And the reason I asked you all these questions is not because I was to make sure that we all are engaged with each other, and B, that as we heard from everyone, right? Environmental interactions, which is sensing. We heard about inferencing. We heard about, LLMs, which is, at best, a generator, right? Data generation or content generation mechanism, or even multimodal data. We heard about learning and decision making. So it's a complex space because we don't have a singular, that this is the modern day definition of AI. All right. So then what I did, I said, okay, let me ask AI what AI is, right? So I asked ChatGPT 4.0. I haven't asked for 4.5 or 5 because these slides are a couple of months old slides. Right? ChatGPT 4.0 says, AI refers to the field of computer science and engineering. I guess AI is only in CSE, computer science, according to ChatGPT, that is focused on creating systems and machines capable of performing tasks that typically require human intelligence. These include learning, reasoning, things that you said. And AI systems achieve these capabilities through algorithms and models that process data, recognize patterns, adapt to new information, and make predictions or decisions autonomously or semi-autonomously. Okay, makes sense, right? It's basically what they have put in this definition is a kitchen sink of everything. So then I said, all right, does ChatGPT, as we all heard from each other, we had a different mental model of AI. Does AI itself have a different mental model of AI? So then I asked ChatGPT o1, it gave a different answer, right? It is intelligent agents. It talks about environment, percepts, actions. It talks about performance measure, objective, or utility. It talks about AI as a rational agent. Now it takes GPT-o1 takes a big leap by calling AI as a rational agent. And I don't believe AI is established as a rational agent as yet. I do not believe AI has reasoning capabilities established or demonstrated that AI actually when I say current versions of AI, as one of your friends in the room said, today when we think about AI, LLM is the AI. I think so. That's the current accessible version of AI or generative AI, and it's the LLM. And that's why, Meta and others are putting billions and trillions of dollars to do super intelligence, reasoning, etc., because that is the ultimate frontier. Can we get these AI agents to be rational, to be able to reason, to be able to plan without any human intervention? We're not there yet. Far from it. So this gives a different formal definition. Again, the point here is the same chat GPT I asked. Depending on how the model was trained, it gives you different definitions of AI, right? And that is a complexity that we face as a field too. And then I asked Cloud, hey, Cloud, what is it? AI. And Cloud had some more connections to GPT-o1 and was sort of a mix. But Cloud gets into narrow, weak AI, strong AI. And Cloud actually is a bit more honest, where Cloud says that self-awareness or rational or reasoning is only theoretical and is not yet achieved, right? Whereas GPT actually formalizes AI to have both weak and strong AI, right? So it's part of the definition. So it is very interesting to see that how different of these systems are also giving a definition of AI, and that was the reason I also asked you to define AI, because I wanted us to realize that each one of us may have a different perception of AI. I may have a different sensibility of AI, may have a different experience of AI in how we are interacting. And when we are working in a field where we do not have, if I ask you about Einstein's relativity theory, if I ask you about defined science, if I ask you about certain fundamental definitions across the domains, in general, we will all give the same definition, a similar definition. But AI, we don't quite know how do we begin to define it, because the field has become so confusing by ourselves, right? Sometimes we think is machine learning. And a lot of AI that we're talking about is machine learning, by the way, right? We haven't figured out reasoning, planning, and all of that jazz, and rational behaviors and etc. within the notion of AI. And then something else that, we throw these words about responsible AI, we throw these words about, fair, ethical AI, etc. But let me show you this definition over here by GPT-o1 as well, where it is maximizing a performance measure that you can write as a mathematical objective function. Can any one of you give me a mathematical function for responsibility? Right? How do you mathematically define responsibility? We can't. So if we can't define responsibility as a mathematical function, how do we optimize on it as an AI algorithm we can't, then how do we say it's a responsible AI algorithm? Right? So there's a lot of these words that are being thrown into this, and that's my big concern about AI as well, that I hope we don't find ourselves trapped into more of a gimmicky words than, and responsible AI is a good thing, but we have to define it, what it is. Right? We must be responsible about how we use AI, how we deploy AI, but we must define it. Likewise, we must begin to define that, hey, machine learning is this, AI is an overarching area that has vision, sensing, perception, environment, and perception actions. And within that overall AI, these are the subfields of AI, etc. So then the question also becomes is that how did we find ourselves here, right? And it's a fairly, 75 years ago, Alan Turing proposed the Turing test in 1950. And then there was a Dartmouth conference organized in 1956 that led to the birth of AI as a field, right? And the conference basically this was the mandate of the conference that which said, we propose that a 2-month, 10-man study of AI be carried out during the summer of 1956 at Dartmouth College in Hanover, New Hampshire. The study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that the machine can be made to simulate it. An attempt will be made to find how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. We think that a significant advance can be made in one or more of these problems if a carefully selected group of scientists work on it together for a summer. 70 years ago, these were the goals of AI. It was supposed to be done in 2 months, over a summer, by a carefully selected scientist. Back in the day, the carefully selected scientists meant 10 men. That was a big mistake, first of all. Right? Maybe that's why we didn't succeed. Had they had some more women in it, we would have succeeded then, right? But my point here is none of these 70 years later, we are still struggling with the questions that they have raised. Now we can see how machines can use language with LLMs. We can see how they can form abstractions and concepts. They are sort of getting better at problems reserved for humans, but not completely. It depends on standardized testing and etc. And improve themselves as well as they need human annotation to improve, but it's not like self-improvement. I'm just watching and improving and getting better. It's not there yet. And we thought we could solve this in 2 months of a summer in 1956, 70 years ago. So this is the point of this observation here, my friends, is that this is hard, right? And then there was so much optimism pasted 1950s to early 60s that symbolic AI, logical reasoning, and in fact, the group, this Dartmouth group that got together in 1956, essentially said the connectionist approach to AI, which was the perceptrons that were coming up at that time, or the neural networks based approaches, will never work. We need symbolic AI and logical reasoning. That's the only AI that will work. And today, some of those promises that are being fulfilled by neural networks that this group said it's not going to be. Right? It has to be symbolic AI. It has to be expert systems. It has to be logical reasoning. None of those worked out. Yes, now there's a group of researchers who are combining neurosymbolic reasoning, but neural networks is what, Rosenblatt's work and things like that in 1950s and 60s sort of survived the test of times. I said, this is how wrong, even as scientists and experts, we can be at that time on the assumptions that we make. Of course, at that moment in time, our assumptions are baked on the basis of what we know, right? It's only 10, 20, 30, 50 years later we go, you know, it was optimism. And then in 1970s, the AI winter happened. Right? By what I mean by AI summer and winter is summer is when things are blossoming. Right now in Ukraine, in Lviv, you have this beautiful summer. You have this beautiful park right by your campus that Alexei had walked me through, and Yaroslav had walked me through last year. Right? It's beautiful. Everything is blossoming, green. It's beautiful summer. Right? You're a beautiful, beautiful city. And then when the winter comes, you don't want to be out, right? It's cold. And that's what is with AI as well. The AI summer, everything was blossoming and flowers and everything else. And then AI winter happened, the funding went down in the 1970s because the entire decade of promises from 1956 to 1960, late 1960s, even early 70s, nothing materialized. We failed. And that led to the AI sort of the down. And then what happened is, and then we went through a couple of these cycles, etc. Then what happened is in 2000s, suddenly we saw a wave of opportunities in the last 2 decades. The last 2 decades have shown to us the possibilities that were not that we couldn't even imagine in 20 years, the progress that we have made in AI. Right? First thing first, what happened? Internet happened. Right? So it's not just that AI itself, we mathematically transformed the field of AI. No, we didn't. We did not, right? We exploited what happened in the adjacent fields. Right? So if it's in the early 2000s, we had data available, recommendation systems, computer vision, NLP, etc., suddenly began to rise. And then the deep learning architectures arrived. Right. So essentially, if you Jeff Hinton, Jan LeCun, Bengio, etc., the neural networks, the convolutional neural networks work, etc. They came up with deep learning phase because neural networks were like, oof, we are done with it. We are tired of neural networks. They don't work, etc. But they re sort of re-inspired neural networks within the umbrella of deep learning. But it was not a deep learning breakthrough per se. Right? The papers or the concepts or the algorithms were established in 90s. It wasn't that suddenly in 2010s we came up with brand new initial algorithms. We have continued to improve on those. But it's sort of, we were able to leverage. And there are two things that we leverage, right? If you think about, one was an ImageNet data set became available by Stanford. And that data set was a collection of massive amount of images. So the data became available, which we didn't have for these neural networks before, or deep learning architectures. And the second thing was these neural networks or deep learning architectures took forever. They were computationally complex. And that's when GPUs arrived. And GPUs, this company, NVIDIA, was making GPUs, and Intel and AMD at that time said, GPUs are the graphic processing units, are for video gamers, and let NVIDIA handle that market. It's a niche market for video gaming and things like that. Let's not waste too much time on it. We are more interested in the more traditional sense of compute, which is memory and memory-based compute and more logic and CPU-based compute. And that's what, other companies are investing in. And then we realized that, hey, the denseness of the GPU could actually be amazing for learning these deep learning architectures. So it was a serendipity, my friends, right? That data became available, compute caught up, and suddenly AI arrived. It wasn't that suddenly we created or I created this amazing new algorithm that revolutionized us, and we could do the old work the way we could. If I remove data, if I remove the compute, we would not be with LLMs today where we are. That is why what you keep hearing is, oh, the entry point for LLM is very expensive, the amount of data centers and compute you need. Billions and trillions of dollars have been invested into building the compute infrastructure. It's because we need it. And this is where some of the research that my lab has been focused on is largely focused on how do we go from to do low resource, etc. things. And this is where what is most fascinating is, right? The LLMs that we are experiencing, think about it this way. 2018, Google had published a paper, Attention is All You Need. And that paper is the foundation for Transformers GPT, right? OpenAI released the first version of their product in 2020 or 2021. It's gotten better. GPT-2 or whatever one was released, BERTs were released, and then now we are sitting on GPT-5 with OpenAI. In less than 3 years. So in 7 years, from the paper being published to a product being out that we all are interacting with, that has defined AI as we know. How fast this field has moved. No other field, even the internet, when we announced it, didn't have this massive adoption rate as we are seeing with LLMs. However, there are still many concerns, of course, responsibility, fairness, etc. And the business value proposition, how do we find value with these things? All right. So in my opinion, machine learning survived every winter. It's not because, as I said, we developed new, better ML algorithms. We had more data and we had more compute. So then I would like to sort of, where we are, I would like to make an argument here. And I'll sort of piece together those arguments as we go. Where we are with AI is a conundrum of convenience versus productivity. It's the ROI conundrum, right? What we have seen so far is I can use my AI tools to help me. By show of hands, how many of us have used Copilot, etc., to write code to do coding using AI? No one?
No.
Yeah, I mean, don't be shy about it. It's okay. Vibe coding is cool. So maybe a couple of folks, right? How many of you use ChatGPT for writing assistance or Gemini or whatever your favorite LLM is, or Llama? A few of you. Okay, great. Excellent. Right? And you find it to be efficient, right? Yes? It saves you time? I can't say because you're on my tiny screen right now. So that sort of is that, we all are using it. We are surrounded by it. We may save time sometime. We may not save time sometime. It's just a mixed bag. But the companies are investing big money, right? Microsoft acquired GitHub for $7.5 billion. And what does Microsoft get? All the code that we deposited on GitHub is with Microsoft. All the code. All the code that we submitted on GitHub as open source is being used to train the large language models. All the code. And the key thing here is, even though all this code is becoming available, the fundamental question is programming language, the code as a language, easier than English as or any language, Ukrainian or what have you, right? And arguably, one could say that yes, a programming language code has a fixed syntax, semantics, and that people follow. Of course, now the challenge with coding is the same code could be written in a more efficient way, and same code could be written in a very inefficient way. And that could devolve into high compute time or low compute time, right? Things could vary. But then the question becomes is, how much does this increase the productivity of a programmer? We have these things. How much is the productivity of a programmer increased by these things?
Again, say something.
All right. And
Here's-
can you help no programmers?
I
So
have
I'll show you a couple of demos now. And this is my student working with real code, and he's using Copilot. And what we see is Copilot is beautifully helping him write comments, complete functions, right? Etc. etc. He's using Copilot as an assistant. He just said document, and Copilot writes the entire comment, right? Saving him minutes. It's efficient.
Can you hear me?
Yes.
Oh, okay.
So I wanted to add something about the productivity. I believe there was a study recently that measured how more productive people are with artificial intelligence and without it. And it turned out that artificial intelligence makes mistakes, and it takes time to correct them, and it takes time to write the correct prompts. And the most productive programmers in the study were the ones that didn't use any artificial intelligence.
Yeah. No, I think it's a mix, to be very honest. I saw that study as well. It is a mixed bag right now, because some have made the arguments that by using AI as vibe coding, I actually say like, and I think what the point that you made is relevant. The example I showed you just now is a good use of AI where the human is still writing the code, writing the logic, thinking about the concept, and AI is doing the busy work, comment generation and all that stuff, right? So that is all any repetitive function calls AI can do. But the human has control on the program, right? So is the human then going to save a few minutes where the human is retaining control of the key intellectual uh, uh, activity of writing code, but the AI is acting as an assistant, as a cheap assistant. Right. So that's what we showed in the previous example. Now, the other example that I'm going to show here is, so how many of us are familiar with the advent of code problem? It's generally asked in job interviews and stuff like that. Uh, and it basically is that and it's a day 11 part 2, the example that I'm going to show you. It's plutonium pebbles, and they grow exponentially over over a period of time. And the naive solution to this problem is to keep track of individual stones in an array. This is where we may have to sort of say that these stones explode, they etc., but they maintain the order over a period of time, etc. So look it up. It describes what this is. So then my student gave the plutonium pebble problem to an AI, to GPT-o1, Copilot with o1, which was the most advanced model available at that time, and asked it to generate code. So here, the AI is generating the complete code. Simply the problem statement has been given to AI. I'll just let it run for a second. So basically, the problem was given to Copilot using o1. and O1 is writing the entire code. All right. So it generated the code without any human intervention. And now it's running at the bottom. And I'll skip it because it will keep running. It doesn't solve. Do we know why? What happened? Anyone wants to guess what happened? It is a correct code. The code was correct. Do you want to guess what happened with it?
Maybe it was time consuming.
It was time consuming.
It was
Why?
like,
Why?
I don't know, nested cycles in Python. Looked time
No,
consuming.
I agree. But the problem, the algorithm is not time consuming. Algorithm. So essentially what happened is, and I'll tell you what happened, So this is where my student now writes the code with a human in the loop. My student starts to write it. He uses AI to provide some support, but he sort of is now having control. And the AI is supporting his developments. Like, AI is able to call certain functions and do autocomplete and things like that. And he says that's helpful, right? That sort of is helpful in making it more efficient. And he writes the right logic, and then he runs and he gets the answers, right? It runs very quickly in linear time. What happens is ChatGPT wrote the code. The code was correct. I should say Copilot using O1 wrote the code. The code was correct, but the algorithm was inefficient. So as programmers, for computer scientists in the room, when we are writing a program, we think about not just is my program technically correct, but my algorithm that is being used in my program should also be correct, right? So the algorithm and the program go hand in hand. I cannot just simply write code which is inefficient and takes a long time to run. There's two kinds of programmers. Programmers that can write inefficient code, programmers that can write efficient code. And the efficient code programmers have a good understanding of the underlying data structures, underlying algorithms, etc. So that's how all of this is sort of put together. So the human in the loop, as one of you also said, right? And this is where the efficiencies and the productivity conundrums are coming up, right? Humans in the loop is essential. We need to check the output. We need to modify and edit. We need to approve. So will AI replace my job? No. But a human using AI will if you're not, and that I am convinced. We have to think about, even from a curriculum perspective, pedagogy perspective. We are at the university, all of us. We either at UCU or Notre Dame or other universities in Ukraine, perhaps. And we have to think about what does it mean to have AI as part of a curriculum engagement, as part of a degree engagement. Because what you have to think about is these corporations are making billions of dollars, of trillions of dollars of investment. They want to see it work. So they look for people how they can do more AI as part of it. It's vibe coding. Meta, Facebook is interviewing candidates. And I interviewed my students and they asked them to use Copilot, etc., to help them write code. They wanted to see how well they can use AI tools to write code. So this is what the future would be, where AI would be your necessary assistant, right? And something that I said even 2 days ago, in Ukraine itself, right, that you have an unbelievable opportunity with the drone industry, right, which is images and data, that the kinds of data you're collecting, the decision making that you are putting on a drone, the decision making that may happen away from a drone, the edge computing principles, etc. What can AI do to super turbocharge that, right? What can AI do to turbocharge other aspects of the economy, whether it's from an agriculture perspective? What can AI do to address some of the other Ukrainian specific problems? What kind of LLM Alexei and I have been thinking about? Is there a Ukrainian LLM that we can build, which is sort of, has some similarities with the Slavic languages, whether with Polish, etc.? Could we build an LLM that caters to the Ukrainian needs? Now, of course, I'm not, investing into billions and trillions of dollars of data center architecture is hard, but could we build low-resourced LLMs, low-resourced environments to solve some of these problems? So that's where some of these things could be extremely relevant. And then, so we have to go from right now, it's fascination about AI. AI is amazing. LLMs, as one of you said, a joy of AI is LLM interaction, right? Lots of amusing and fascinating capabilities. How does it help the, we got to get to demos, etc. Right? And we have to also think about these things in a very responsible way. That today, when I talk to you even about the timeline, in 5 years, 6 years, 7 years, how far we have come. In 2 years, we have gone from GPT-3 to GPT-5. More and more data. We don't know what's ethical, what's not ethical. We don't know how the data was annotated, labeled. There are different issues with it. And so we have a significant responsibility in thinking about how we behave, function, and use these technologies, right? And what I'd like to argue is that there must be the idea of a beneficence of AI technologies, right? At the end of the day, when we do any intervention, medical intervention, etc., we say that we will not conduct interventions that will harm others, right? That's good in science. We don't simply experiment on we will kill half the race for this experiment that we are doing for this new drug or treatment or what have you, any basic science that we're talking about. And we will not harm others. And at the same time, we will achieve maximum benefit. So that sort of is, could we begin to think about AI technologies from that perspective, where we have duty of non-malfeasance and we have benefit maximization? So I'll talk about a few cases from a lab that we have been working on using these LLMs, just to give you an idea, just to inspire some ideas that think about what can be done from a Ukrainian perspective. You have an opportunity here, right? That whether it's a and unfortunately it's been a crisis moment for all of you for a couple of years now, right? And sometimes in these crisis moments, invention, innovation comes about, right? The society needs you, uh, all of you, and all of us in Ukraine to develop solutions that could be solving some of the most critical challenges that your community may be facing, that the local government may be facing. I was in Bogota, Colombia, about a month ago, and it was a Bloomberg's top 50 cities challenge, and I was representing our city, which was selected in the top 50, that final as a finalist, and there was Kyiv from Ukraine was a city as well, where they were thinking about at that mayor challenge, what can we do? The team from Kyiv was looking at what can we do to make a smarter city using AI, using data. Perhaps similar things can be done in Lviv. Right? Similar things could be done from a local context. So think about the challenge problems. But anyhow, so this problem that we worked on with Colombia, the country of Colombia, was on the peace process. So as you know that the Colombian armed conflict, from about 50 years, has been the most prolonged and complex in modern history. About 500,000 homicides and who knows, countless more lives lost. This is just accounted homicides and lives lost. And then in 2017-18, there was a peace process that was established. And as part of the peace process, there was a Truth Commission that was established. And the goal of the Truth Commission was that we will capture stories of people about humanity, about their lives, and everything else. And all of this data was collected. We have about 2,300 interviews with 9,000 people from indigenous communities. We have 2,200 interviews with farmers. We have thousands of interviews with victims and victims' organizations. We have interviews with folks from journalists and academia. We have community action boards. We have women. We have LGBT communities. We have students. We have all kinds of interviews are established in this. So essentially, as part of the Truth Commission, they collected stories about people affected by the war in Colombia, how they felt, the videos, the justice they felt or didn't feel. Because peace process within and this was a civil war within the country. It wasn't another country invading or having a war. It was a peace. It was a civil war within the country, right? So there's always one side versus the other side, but everybody's a Colombian, right? So what kind of, you either are a victim or you're a perpetrator. All of those voices were captured, videos, dialogues, interviews, etc. And then we basically said, can we make these interviews more accessible? So we built a local LLM using knowledge distillation, RAG, etc., where we fine-tuned this LLM on the interviews and multimodal data that was collected as part of the Truth Commission. And so we trained that. We, of course, use the large language model of Llama, etc., but we also fine-tuned ours. And I'll show you a particular example, right? So on the right, you see GPT-4, and then Ventana a la Verdad. That in Spanish means window to the truth, right? And then we have GPT-4. We asked the same question. How did individuals resist or subvert the influence of armed groups in their regions during the Colombian armed conflict? We asked this to ChatGPT 4.0, and GPT-4 gave us a very general response. Our GPT trained on specific interviews, videos, images, etc., references, gave a much more precise response. And the point of this example here is these language models are more general purpose. Right? Whether it's ChatGPT or Gemini, etc., they've been trained on the universe, billions and trillions of documents. They could care less about a very specific problem. It's highly imbalanced, right? Very specific problems like a Colombian armed conflict, which has only tens of thousands of interviews as compared to billions of other things that they have seen. They give you a very specific general answer. All right, whatever. But in this case, in the answer that we provide through our chatbot, we talk about the challenges that the LGBT community was facing. We talked about the challenges that indigenous people may have in Colombia. We talked about rural populations. We talked about other forms of resistance. We provide references grounded in literature and facts. None of this happens with GPT. So the example of this little quick demo here for you folks is that think about what can you do from a Ukrainian context and build a local language model to address it, right? And, very different questions, different kinds of responses that it sort of gives. And we ask the same question even in Spanish. It doesn't matter. This was a question that was asked in Spanish. And we were language-wise as well. we were able to go back and forth between Spanish and English. GPT went back and forth between Spanish and English. So did we go back and forth between Spanish and English as well. Something else I've been working on as well is for a healthcare application. And again, I'm just going to drop a few applications, use cases, just as I said, the idea is to inspire. Now, this hospital is the largest pediatric cancer hospital in Mexico City. And they still have paper-based records. What I'm showing you on this thing is how they maintain records of population, paper and pen. All right. So, and this is the team that we are working with them. And so what we are building for them is a language, a med LLM, where we will have chatbots for caregiver. Caregiver is the family, and this is pediatric cancer hospital. So the parents, grandparents, legal guardians may use them. The hospital may have a chatbot, and they're using these things to sort of interact with a common database and arrive at solutions. And then what we have done is we have built what we're calling Salute, or automatic speech recognition system, where these are families don't have too much education, etc. So typing, writing is difficult. We are using automatic speech recognition. We use voice over mobile phone networks to reduce technical requirements. We use AI-driven workflows to get the answers. And we are customizing the tools to take context into account. And this is how we are using right now. A report is communicated via voice and converted to text. And relevant information and based on the text, we get the right information from the LLM. And then it goes back to the user as a text or a voice. So it is very compelling, right? So user asks a question on the phone, hey, about some health concern they may have about their family member. And then the end user gets it, and it comes back to the point. In addition, and so these kinds. So again, the question, the point of this as well is, we took a problem. We said the hospital does not have a structure, have a electronic medical record. We are solving that problem for them. And then we said for us to reach out to the families, they should be able to do speech. It's easier. And then can we retrieve, once based on the thing that they're asking, can we retrieve that information from a medical LLM that we have also constructed and answer those questions and make it easier for the end user? Again, you may think about it as well, that is there such an LLM chatbot that you can build from a Ukrainian context? Is it something that folks in the battlefield may need, and they can do a voice-based entry, and that goes as text, and you have an LLM trained with the specific context, and that's giving the answers back very quickly. So again, think about technology is there. Possibilities are tremendous with the availability of a variety of the modern day technologies. What can we do? And then we are also working on a large language model to identify biases against homelessness, right? In the US, about 770,000 people in the US experience homelessness in 2024 for a single night. So what we are trying to say is that, okay, what kind of biases, hidden biases people may have against homelessness, for homelessness, over a period of time, because it's not that people choose to go homeless, right? They're homeless. How do we support, how does society react to them, support them, etc., to be able to either get back on their feet? So we have built this lexicon as to how people are talking about these homeless people, unfortunately, online, in news, in the meeting minutes, etc. And this was a paper in IJCAI this year. Both this and the Mexico paper are in IJCAI in Montreal, and that's why I couldn't be in Lviv, because we had to be at IJCAI as well for the conference a couple of days ago. So we have all of this data coming in. Can we build LLMs to, again, tackle these problems? Again, the idea here is that can we get to solve a societal problem? We have shown 3 use cases: peace processes in Colombia, healthcare in Mexico City, homelessness in the US. And finally, we're also looking at the use case of teaching, where what we're trying to get to is how AI attitude and literacy could be maintained as part of a curriculum engagement, right? How do we combine, how do we motivate instructors to use AI as part of the classroom? How do we do it through a flexible and incremental information collection stage? How do we do scaffolding of AI adoption? And we have built this chatbot wherein people can interact with this chatbot and ask questions about student missing classes or things like that. We're essentially a small teaching-based modules that we are incorporating and making it available for instructors at large. Hey, I do realize that that should be it for me for today. I'm tired as well of speaking for more than an hour. And I'm sure you're tired of listening to me for more than an hour. So I'd stop here and I'll ask if you have any questions. If not, thank you again for engaging with me.
Nilesh, thank you so much for the exciting talk. Let me ask you the following question. In Ukraine, there is indeed a great need to create local labs for various purposes, either bureaucratic, from bureaucratic to educational to et cetera, et cetera, et cetera. And what would you advise to start with for the institutions which are underfinanced? For example, at times we can do this service somewhere in cloud, at times we cannot. At times we should have our local server, et cetera, and at times there is no financing for that. And what, in terms of like in developer terms, what would you advise to look at first if one has experience in ML, but for example, not an expert in LLMs?
No, I think that's an excellent question, right? So something that I've often talked about is how do we think about our research in a low resource setting, right? And low resource is a relative context. In the US, universities have lower resources than the big tech, right? Where Microsoft or Google or OpenAI or X or other kind of tech companies, Anthropic, are spending billions and billions of dollars on computing. And the universities do not have that money, right? So we are low resource. Low resource in Colombia, Mexico, where I work with, is a very different context, where access to even some of the basic compute. And in Ukraine, it's also a different problem, right? As you're thinking about. So we have to sort of ask, like even when we build this in Mexico, the work that we're doing in Colombia, what is my local challenge that I should be focused on? Make it more problem specific, and then think about what are this knowledge distillation based frameworks we can apply or fine tuning of LLMs that we can do to create a smaller federated language model where you can say thank you to Llama or thank you to Cloud or thank you to the other language models that have made their parameter space open source. So you don't have to train the entire language model, but your focus is on collecting the right kinds of data for that problem that you are trying to solve and doing a smaller, a smaller knowledge distilled LLM at your end to solve that problem. So focus on that. Focus on what would be the human experience on interacting with the problem. Focus on what will be considered success if I solve it in this Ukrainian context. Focus on maybe the drone industry, which Ukraine has has sort of gone leaps and bounds in terms of drone technology today. What kinds of data are being collected, modalities of information? Can we do something more on those to understand, maybe the land mass and deforestation and ag and other things in addition to security users? So again, narrow down the problem statement from your context. Think about the specific data you can collect to your context. That data would not be the universe data of the whole internet data. And then say, okay, thank you. Think about having access to some compute. You do need some compute where you can host the language model, the larger one, and then the compute requirements are not that extensive.
Maybe let me ask you several quick questions if you still have time and resource for that. Do you agree that like 7 billion parameters is the low end to start with? I heard that people in the industry, for example, in Ukraine, gathered on some event, and this question was asked from the audience, and the answer was like 7 billion, and it's like maybe 4 powerful GPUs or something.
So I don't know the compute requirements. I don't know how many GPUs, etc. But DeepSeek has shown us, right, that at a much lower cost you can build a language model. And what DeepSeek also has shown us that DeepSeek relied on the bigger language models for its own success, right? And now we're not talking about DeepSeek as much because it has its own limitations. But like my students share a compute infrastructure in terms of GPU of maybe between about $1 million US, right? Which is not much given the investments companies and people are making, right?
Yeah.
And we are able to I have 10, 12 students. We are able to get our papers out. We're building out some good systems. But I don't know how many GPUs is somebody's using for what and for what resource, etc. But just to give you an idea.
Maybe let me ask you one last thing. To be more API and problem specific, perhaps let me at times consult with you via email, since Alexei will share it with us. So I might be even more problem specific, so that now it's like hand waving more or less.
Yes, I think yes. Send me an email, please.
Thank you.
Okay, cool. Any other question?
Second, yeah.
Yeah, maybe one last question is, in Ukraine, you said that we have a lot of opportunity now. It's true, but I don't think that we have any opportunity now which does not connect to the war, right? So people do not see any investment right now that does not increase our defensive ability as worthwhile currently. So I think that like any abilities, any things that we try concerning like LLMs should be either from if we take money from government budget, either defensive or something like this right now. So what do you think, like what do you think are the possibilities that can be connected to Sphere right now, right? Because like I think you know this, but Ukraine actually started an initiative to build a sovereign LLM right now, and as far as I know, maybe people who know can correct me, but they want to build an LLM that will be for businesses, right? So businesses will finance it, and they will use it later. For example, banks, their AI assistants, right? You cannot just send data to Google, right? So this works, but if we spend government money, we need defensive applications. So what do you think are the applications?
No, I think I don't know, right? I think it's an open speculation. It depends on the conditions that the money is given to you on, etc. But I would also say that a lot of, even if you think about ARPANET, internet was a defense that led to, so a lot of these defense-based applications lead to a broader civilian use cases as well. Right. So maybe because when you're solving those, it's not that the defense problems are so from the other planet, right? At the end of the day, you still have problems that you have to deal with multimodal data. You still have problems where you may have to build an LLM specific to Ukrainian or Slavic languages and things like that, right? So once that is done, then they become general purpose. Right? So a lot of there has, at least in the US, right, it's been a beautiful synergy between defense-sponsored research, defense-based research, and basic foundational science research. There's a nice interaction serendipity that happens between the two.
Yeah, thank you.
Thank you all.
Yeah,
Thank you, Alexei.
lectures, and yeah, we are waiting for you in Lviv next year. I hope we can do this. This would be great. Yeah, so it's actually the last lecture, and tomorrow we will have a project, but early. So I'm afraid that you will have night, still have night on this time. So thank you, and yeah,
Have a good one, folks.
let's be in touch. Yeah.
Yes. Take care. Thank you. And all of you, please feel free to email me if you have anything that comes up in your head. Thank
Okay. Yeah, so, thank you. So yeah, you are the best. You told till last lecture. So now you have time for doing your projects and together your team. If you have any issues or problem with connection to your mentors, ask me. I will send you mail or maybe something, but I hope you already did it, made some letters, and you have time for today evening and tomorrow morning, and tomorrow at 10 we will start projects here. I remind you the rules. Each team has 10 minutes. Yeah, it's better to keep up to 5 slides. That's my experience. So up to 5. You need clearly define who is in your team, what is the problem, and what is your approach to solution. And then we will try to listen and give you some feedback about this. And if you already have some preliminary results, you can also include them. Okay. So yeah, thank you. That's fine. Yeah. Thank you.